Now, to provide a little bit of background on teams, because I keep referring to these literatures that have been studying teams for decades. And again, this has primarily come out of things like industrial organizational psychology or organizational behavior, basically business schools and psychology departments, but also people in sociology and anthropology. They've also studied organizations. So a number of different disciplines have tried to understand teams in organizations. So these are just some of the representative definitions. Teams are independent collections of individuals who share responsibility for specific outcomes for their organizations. Another one, teams are two or more individuals who must interact and adapt to achieve specified, shared, and valued objectives. So the idea here is interdependency and shared something or other, shared objective, shared goals. That is, they need to bring together their different forms of expertise and achieve a common outcome. So some of the defining characteristics in order to do that are you have multiple information sources, you have these task interdependencies, you need coordination, you have specialized roles, common value goals, task-relevant knowledge, intensive communication, adaptive mechanisms, and they're hierarchically organized. You can basically take these bullets and see how it applies to scientific collaboration because you are essentially having the same kind of characteristics. So multiple information science sources. You have different sciences working together to address a particular problem. You have task interdependencies. If you want to produce a scientific outcome, you need to fit these things together. You need the coordination among members, but you really have this kind of specialized roles and the specialized knowledge that comes from the disciplinary knowledge of the people you're trying to bring together. Thus the point that you can take what we know about teams and now look at it with that analytical lens in the context of scientific collaboration. And another point I wanted to make, though, is there's different kinds of teams. Traditionally, what has been studied are work teams and action teams. So work teams tend to have static membership, well-defined roles, they work in a particular area, and the work is relatively routine. You can think about management teams. A large part of the research, though, has been on what we call action teams. So these are things, for example, like the military or in aviation, where you can have fluid or static membership. There's well-defined roles. It's highly specialized, but there's high stress. Oftentimes the events are not routine and they're emergency situations, so something like an emergency response team. But the one I wanted to point out that I think is most relevant are project teams. So these are things that have rotating membership. It still has well-defined roles. The technical requirements and the outcomes are specified. That is, we're bringing together experts from these different disciplines, and we're bringing them together to solve X or produce a new product. And they engage in problem solving and decision making. But the important difference here is the tasks are pretty much not routine and they unfold over a long time frame. So I mentioned product development team, but I think this is the example of the type of team that is most relevant to science. So the literature in teamwork that's most relevant to scientific collaboration is what we can call project teams. So think about it or reflect upon the projects that you all have seen or that you all have studied about. It's essentially a project where people come together to respond to maybe a proposal request that the National Science Foundation has put out that says we need to understand X. So like, okay, well, if I want to understand X, I need a scientist from discipline A, from discipline B, from discipline C, and you come together, you have these specialized roles, and you produce a plan that's going to help you work on this project and produce the knowledge that's going to solve this problem. Another relevant issue with regard to the science of teams is this notion of teamwork, phases of teamwork. And Michelle Marks and colleagues, they argue that teamwork is cyclical in nature and it requires mutually dependent interactions, but there's these temporal cycles of goal-directed activity. And what they meant by that is we think about teamwork as transition and action. So they say there are transition phases where you have activities such as evaluation and planning, and these transition phases are essentially in support of meeting objectives and goals. But then there's the action phase. That is where the teams actually come together and do things. So work activities are specifically performed, and these directly contribute to meeting the goals. And teams cycle through these action and transition phases. And with regard to your center and what little I know about it, I think that you do support action phases at the center. So I just saw your conference room where you have these meetings where people are brought together. And what's unclear to me, though, is what you're doing at the center. Because to some degree, I think you're involved in planning, And this is where the ambiguity comes in with regard to what do we mean by scientific collaboration, because there's these different phases of collaboration. We talked earlier about this notion of problem finding, where basically you're coming together and you're trying to think about what problem are we trying to solve, and then once you figured out what problem you're trying to solve, you go through the planning stages, and then the work actually gets performed. So the scientists may go to their different universities, work on their piece of the puzzle. They may come back together, talk about what they've been finding. They're going to be interacting using the kind of cyber infrastructure that you all put together for them. But there's all these different phases of interaction that vary with regard to the amount of interdependence and the amount of interaction. And I bring this up here because this is an important concept in the study of teams in different settings. And what's unclear to me is the degree to which we need to develop an analogous or adapt this definition of teamwork for scientific collaboration, because I don't really see a neat one-to-one mapping in scientific collaboration, but this is an accepted theoretical concept in just the study of teams in general. And I think it's an important one in those settings, but when it comes to scientific collaboration, I think we need to do better. Another important concept that I think is relevant to what I see happening at the center is this notion of multi-team systems. So multi-team systems is an idea that originated about a decade ago, where they talk about two or more teams that interface directly and interdependently in response to environmental contingencies toward the accomplishment of collective goals. So one of the first examples where this was studied was emergency response teams, where you had people like fire department and ambulance and police officers all trying to work together at an emergency situation. And they are essentially a team of teams trying to address a particular problem. What's important to recognize is that these sub-teams can have conflicting goals, even though they're trying to achieve the same outcome. So a conflicting goal, for example, would be where the ambulance personnel need to try to save someone's life, but the law enforcement personnel need to protect people in that area as well. So the ambulance people may need to go and put themselves in danger or put some other people in danger in order to save lives, and law enforcement may have a different goal, and they have to manage that goal conflict in order to come to a resolution and decide how to proceed to solve that particular problem. And that's just a kind of a simple example to illustrate what we mean by multi-team systems. But this is an issue that's become increasingly prevalent because organizations more and more are relying on these kinds of multi-team systems. And when talking to Margaret and John here about the center activities, I think some of what you're doing are multi-team systems. So you don't necessarily have a team of 20, you have a multi-team system of 20 people with sub-teams of 3 or 4 people involved there. And I think what you need to do as a center is be clear on what are you supporting. Are you supporting just a team, or are you supporting a multi-team system? Because different dynamics are going to emerge, and those different dynamics are going to need to be managed by whomever is facilitating or leading this kind of team. So next I want to talk about kind of a heuristic that we use in team research. We refer to this colloquial as the ABCs of teams: the attitudinal or affective component, the behavioral component, and the cognitive component. So this is a heuristic where we talk about teams think, they feel, and they do. So with regard to the way teams think, with the cognitive construct, so in the team literature, we discuss things like mental models, metacognition, decision-making, and problem-solving. So metacognition, in my conversation with John and Margaret, they mentioned the reflective activity often engaged by the science team members. So you're thinking about what is the problem you're trying to solve. So you're reflecting on your own cognitive processes and trying to understand the situation, and you're also trying to understand the team dynamic that's going on within that team. So this kind of metacognitive activity in science teams could be, for example, well, is the environmental scientist really understanding what the economist is saying about this particular problem? Or do they just disagree because they have a different fundamental worldview? So you would need to be metacognitive from the standpoint of, is a disagreement that's emerging due to a lack of understanding? Or is a disagreement that is emerging due to the fact that they just don't think that this is the appropriate way to solve that problem? Because as you're well aware, economists see the world in a certain way, environmental scientists see the world in a certain way, psychologists see the world in a certain way, and you need to be metacognitive about these worldviews in order to come to an integrated understanding of the kind of scientific collaboration that you're trying to pursue. We also talk about the attitudinal components in teamwork. So we use things like group and team cohesion, collective efficacy, collective orientation, and trust. As an example of collective efficacy, do the team members think that they actually have the capabilities and the competence to solve this problem? I've been on teams before where I think we really don't have an expert in discipline X. So I'd say that our collective efficacy would be low because, for example, if we need a top-notch computer scientist on this team who can model cognitive processes for us, then we'll be more effective in the scientific problem we're trying to address. And as I said, sometimes I've been on teams where I don't think we have the right disciplinary composition. Another issue with regard to science collaboration is this notion of trust. So different disciplines may have different levels of trust for other disciplines. So I know that the life sciences may not trust the social sciences. As a social scientist, my degree is in psychology, and when I've interacted with people from the life and biomedical sciences, I can tell that there's a different level of trust there. They may listen to me, but they don't really trust the methods that the social sciences use. So this has been a continuing debate in the different disciplines. And last, with regard to this notion of the behaviors, in team research, we talk about supporting and backup behavior. We talk about the forms of communication necessary. We talk about leadership. We talk about performance monitoring. Earlier, John mentioned this idea of awareness within the team, and we label this mutual performance monitoring as one of the ways to think about it. So are my team members watching what I'm doing? Am I watching what they're doing? Am I sure that we're really achieving the goals that we're trying to achieve? Do I understand what particular issue we're trying to address at that point in time? The reason this is important, if I see a teammate struggling with something, so if they're trying to work on something that I've just tasked them with, and I see them struggling, then I need to step in and engage in supporting or backup behavior. So you need the performance monitoring in order to engage in the kind of backup behavior. Yeah, these are just simple examples of a whole list of the kinds of constructs that get studied, and I just wanted to present them here because, as I said, this is the heuristic that we often use to then develop the models of teamwork in different settings. But there are many other types of behaviors. There are many other affective or attitudinal issues, and there's many other forms of knowledge requirements. And the reason I wanted to bring this up is I think it's a useful way to try to analyze team collaboration. So you want to diagnose what's going on. Is there a cognitive issue? And I think there's lots of cognitive problems that arise with interdisciplinary teams because they're coming from different disciplines. They have different terms to describe their concepts. And because of that, there's not a lot of cognitive overlap, and you need to resolve that lack of overlap for the to have the productive collaboration that you're trying to pursue. And there's also these affective and attitudinal components. Sometimes members of a scientific team don't want to work with other members of a scientific team. So there's, as I mentioned, this problem of trust. Another big issue is sometimes scientists just don't want to work with other people. So they have a low collective orientation, as we refer to it. So they feel forced to work on this team. And you guys are in a little bit situation at your center because the people that come to you are the ones that do want to collaborate. But at other places, oftentimes they don't want to collaborate with each other. They're like, I'm happy working with just myself and my students. No, thank you. I'm going to work only in my lab, and I don't really want to interact with people in other labs or other disciplines. But someone pointed out I need to be somewhat careful with that because even if you are one of these individuals who doesn't want to work with other labs, to some degree you're still a team because you may have a postdoc in that lab and you have graduate students in that lab. So you're still a team, but it's a different form of team at that point. And that's, I would call, more of a unidisciplinary team. But just as some examples to ground this for you, anyone that's been on a plane can thank team research because safety in aviation has improved greatly by adopting some of the findings in team research. So one of these is crew resource management. And this was a technique that NASA helped develop through the Aviation Safety Reporting System. And the Federal Aviation Administration and NASA do an excellent job documenting errors and accidents in the cockpit. So when something goes wrong, lots of reports get filed and they try to analyze what went wrong to try and improve that process. And what they found was that human error was a large contributing factor. So what they implemented was training that focused on teamwork to mitigate any of the problems. So they looked at things like leadership and interpersonal communication and decision making. And to give you a specific example, sometimes they would find that a navigator in the cockpit knew something was wrong, but because of the authority structure, the hierarchy, they would not stand up and say something to the pilot. because there was this dominant authority structure in there. And had the navigator spoke up and said, I'm sorry, there's a problem, the plane might not have crashed, or they could have avoided that error. So they had to implement, I mean, you laugh, but trust me, there's this strong dynamic that emerges where people won't speak up to an authority figure, and they had to implement training to help overcome that. So the pilot would recognize, I need to listen to people, and the subordinates would recognize it's okay to speak up and tell the pilot, for example, you're wrong. This program here, Team Steps, is one of the programs that the medical community adopted. So the Institute of Medicine back in 2001 wrote a report that was called To Err is Human. And what they identified is that medical error is killing, I will say like 100,000 people a year, an outrageous number, where medical doctors were making mistakes. And it was a very similar type of issue where, for example, a nurse knew something was wrong in surgery, but was afraid to speak out and tell the surgeon, you just did something wrong, or I think there's a problem here. So Team Steps was one of the methods that was implemented. This was actually funded by the Department of Defense initially, but now it's been implemented in hospitals around the country. So team strategies and tools to enhance performance and patient safety. So they train people on the skills like leadership and communication. They train people on knowledge, like this notion of shared mental models. Do we all know the same thing that we're trying to address? They train attitudes for mutual trust and team orientation, and they train for performance, this idea of adaptability, efficiency, and safety. So this is another example that's reaching into your all's lives where studies of teams have been applied in other domains. So just to sum this up, teams are studied along multiple dimensions. We talk about attitudes, behavior, and cognition. They're examined in multiple contexts, from military to aviation to healthcare and business. But in team science, what we're seeing is, although there's some similarity, there's still some differences. So in team science, the emphasis is on knowledge-intensive teams. These are people who have years and years of experience behind them. They're brought together to solve complex problems. And another important element is this idea that the performance periods are extended over long periods of time. It's not like in a cockpit where you have a 1 hour to a 5 hour flight or a 10-hour flight. It's not like in a surgery where you have a 1 or 2 hour surgery. It's not like an emergency response where you have a 30-minute interaction. In scientific collaboration, the dynamics unfold over time and space, over longer periods of times. And most challenging is this idea is that you're trying to solve ambiguous problems. It's not a routine type of problem that you're trying to solve. You're literally operating in an unknown problem space, and that is the beauty and the challenge of scientific collaboration. How do smart people come together and try and resolve these ambiguities?